Hey students, this is Dr. C, and don't forget you have your weekly problem set due next Tuesday. So just wanted to give you some pointers and guess in case you're having trouble getting started. So this is problem number 1 on the weekly problem set, and you see I have it basically set up where we have A at -5, 4, B at 6, -2, and we've graphed the function f of x equals -2x minus 6. So we know that point C, and I'm going to grab point C right now and put it anywhere on this line here. So let's call that point C. All right. And then we can kind of construct the triangle that we're going to have. So one of the sides of the triangle, of course, will be AB. And then the other side will go from A to C and also C to B. And the goal here is to make this triangle a right triangle. So it helps if you would first just kind of see it visually to know, approximately what you're looking for. So if we imagine dragging C, and with this program we don't exactly have to imagine, we can see it. We pull C this way, we should be pretty convinced that no matter how far we pull C that way, it's never going to be a right triangle. So let's try moving C this way. And we can see that at some point, it appears at least, that that is going to become a right triangle. Okay. And if we continue that thought process, we can see that here, again, it appears that we can have it be a right triangle with the right angle at B. So that should let us know at least that there are two solutions to this problem that I'm looking for, at least two. So as far as how we're going to find those solutions, I just want to bring up one key point, and that is this. This point C, as you can see, is a variable point. So it can be anywhere that's on that line. And even though it's variable, it does have to follow certain rules. So we're going to name that point. And let's see if I can do that. Okay. So instead of calling it C, I'm going to call it X, comma. And if we were to think about it, if the X coordinate is whatever it is, the Y coordinate has to be a certain value based on the value of X. And that value is 2 times X minus 6. So we could think of those as the coordinates of this point C. So C will be always at that coordinate. And let's just move that so we can see it. So in other words, no matter where we have C, it always has to be X and 2X minus 6. Okay, so why is that useful? Okay, well, for instance here, we know that we want to have a right angle, in this case, at the vertex C, which means that segment AC, or line AC, would have to be perpendicular to line BC. And before I say too much, we do know about the slopes of perpendicular lines, so we ought to be able to set up a problem that would lead us to know the coordinates of C. So again, just said I was going to give you some pointers. Hopefully those few pointers get you on the right track, but still you have some work to do. Good luck problem solving, and don't forget this is due on Tuesday. All right, see you in class.